every truly brilliant product, every single game-changing invention, it doesn't just start with a flash of genius. It starts with a plan, a really, really good plan. Before anyone turns a single bolt or writes a single line of code, a perfect brief has to be crafted. And today, we're diving deep into that crucial and frankly often overlooked step. And this right here is the foundation for our entire explainer today. What you're looking at is the complete 10-step design process, and it was developed by the brilliant Dr. Kwasi Osafo-Ampadu. It's a proven blueprint for how to create, well, just about anything. And we're going to zoom in on one absolutely critical stage, writing performance specifications. So here's our roadmap. We'll see exactly where performance specs fit into Dr. Ampadu's larger blueprint. We're going to talk about defining the problem. We'll get into the super important distinction between what and how, and we'll explore this cool idea of freedom through constraints. And then we'll even run a little test to see it all in action. Let's get into it. Okay, so it's really important to see where performance specifications live inside Dr. Ampadu's 10-step map. They are not the starting line. Note, they come after you've identified a need, done all your background research, and have set a crystal clear goal. They're a foundational piece of this whole design methodology. So what in the world are they? Well, according to Dr. Ampadu's framework, performance specs are simply a set of clear, measurable criteria that define what a system has to do. And here's the magic part, without telling you how it has to do it. It's all about defining the destination, not dictating the specific route you have to take to get there. And that brings us right to their main purpose. Dr. Ampadu says the number one job of these specs is to carefully define and constrain the problem. It's kind of like drawing a box around the challenge. That way, you can build a solution, and just as important, you can actually test if your solution works. Now, Dr. Ampadu uses this really powerful analogy here. He says to think of your performance specs like a contract. It is a binding agreement between you, the designer, and the project's goal. It's the standard you're going to be measured against. Did you deliver on the contract? Yes or no? It's really that simple. Okay, everybody, listen up. If you only take one single thing away from this entire explainer, please let it be this next point. Dr. Ampadu emphasizes over and over that the most critical concept to get is the difference between performance specs and design specs. And this chart just lays it out perfectly. Performance specs, over on the left, are all about the what, the end goal. And because of that, they leave all this wonderful room for creativity. But design specs, on the right, they define the how, all the nitty-gritty implementation details. And that actually handcuffs you. It restricts your creative options because you've already decided on the method before you've even had a chance to brainstorm. And here it is, straight from Dr. Ampadu himself. It is unwise to attempt to specify how the goal is to be accomplished. And why is that? Well, because figuring out the how is the whole point of the next phase, the creative, brainstorming part. If you jump the gun and define the how too early, you kill innovation before it even has a chance to breathe. This all builds up to this fascinating, almost paradoxical idea that the right kind of rules don't limit your creativity at all. In fact, they focus it and they unleash it. It's a concept that Dr. Ampadu calls freedom through constraints. You see, the real art of writing a perfect brief, just like Dr. Ampadu lays it out, is to create boundaries that are really clear but not suffocating. The goal is to define the size and shape of the playground, not to dictate the exact game you have to play inside it. And that allows for a massive range of innovative solutions to pop up. Okay, I know, this has all been a little bit abstract, right? So let's make it real. Let's make it concrete with a fantastic, practical example from Dr. Ampadu's own work. We're going to imagine that our project is to create something he calls a grass shortener. So here are a few of our sample performance specs. The device needs a self-contained power supply, it's got to be corrosion resistant, it has to cost less than $100, and it needs to shorten a 1/4 acre of grass every hour. And notice, it doesn't say lawnmower, it says grass shortener. That's totally on purpose. All right, let's test this out. Take that first spec, self-contained power supply. Does that automatically mean we have to use a little gas engine? What do you think? The answer is a big, resounding no. And as Dr. Ampadu notes, this is a perfect example of a great performance spec because it leaves the door wide open. It could be a battery. It could be solar-powered. Maybe it's some other clever thing we haven't even thought of yet. the designer is totally free to innovate and find the absolute best how to meet the what. Okay, let's try another one. Spec number 2 says the device must be corrosion resistant. Does that mean we have to build the whole thing out of super expensive stainless steel? Is that the only way to meet our contract?
And again, absolutely not. Dr. Ampadu points out that this is the real beauty of focusing on the what. The goal is corrosion resistance, right? Well, you could get there with special coatings or different kinds of plastics or maybe some galvanized parts. The spec empowers the designer to find the smartest and often the most cost-effective solution.
So let's bring this all back home. Let's land the plane here and focus on the final takeaway. What's the ultimate role of these specs in any project you're working on? You know, this mind map from Dr. Empadu's work really says it all, doesn't it? A great performance spec defines and puts a box around the problem. It serves as that all-important contract. But, and this is the key, it does all of this while fiercely protecting the designer's freedom to be creative. So why does all this matter so much? Well, because when you get this right, you've clearly defined the problem. You've created a testable contract for what success actually looks like. You've preserved creative freedom. You've stopped yourself from getting locked into one solution way too early. And because of all that, you've created the perfect environment for true innovation to flourish. So that leaves us with just one final thought. The next time you start a project, it doesn't matter if it's building an app, designing a physical product, or even planning a big event. Just ask yourself this. How are you going to clearly define the what before you and your whole team get completely lost in the how?